Hi, so now we are doing next question. This is from sample paper of 2018. This is new from new specification. This question was asked. So, child P throws a ball towards child Q at a speed of 20 meter per second. So this is 20 meter per second. Okay, and look at the path it followed, and this is 20 meter per second. So when it was thrown at this angle, okay, but at what angle? At 75 degree to the horizontal. So 75 degree to the horizontal, it will have a horizontal component of the velocity and vertical component of the velocity. Okay, and you guys already know that the horizontal component is horizontal velocity is u cos theta, and vertical velocity is u sin theta. Okay, okay, so now they said, now while this ball is in the air, so this was thrown first, a second ball was thrown but with less angle. Child P throws a second ball into the air at 20 meter per second, same like before, but this time at a reduced angle to the horizontal, that's 15 degree to the horizontal. Both balls reach the child Q at the same time. Okay, now the question they asked is, determine how long child P should wait before throwing the second ball. Okay, you see, they both are covering the vertical distance as well as here also traveling vertical as well as horizontal. But can you see both of them travel the same horizontal distance? Okay, that is one hint in your mind. And also both of their final displacement is zero, because they returned to the same place, the ball returned to the same place it was thrown from. Okay, so if I can find how much time does this ball takes and how much time does this ball takes to come to the same point it was thrown from, and if I minus, sorry, this will be t2, if I minus both of them, let's say t1 minus t2, I will get the difference in time this child P should wait before he throws the next ball. Okay, one hint we know is that our S is 0, the final displacement for both the ball is 0. Okay, and we can find their time very easily. Remember, we are talking about vertical displacement, not horizontal displacement. Horizontal displacement is not 0. There is horizontal displacement, but vertical displacement is 0. Since we are trying to find vertical displacement here, we will always use vertical velocity, not horizontal velocity. And what is vertical velocity? U sin theta. Remember, if we want to find the vertical displacement in the equation, we have to use vertical velocity in the equation. Okay, if we want to find the horizontal distance in the equation, then we have to use this. I hope you guys remember this, u cos theta into t ut, because in horizontal distance, horizontal side, a resistance is ignored, and it's traveling at a constant velocity, so there is no acceleration is 0. So s equals to ut is your, or u cos theta into t is your equation for horizontal distance. Here we are not doing anything with horizontal distance, we are doing with vertical displacement, that is 0. Okay, so let me do for first throw. So let's talk about first throw. At first throw, your displacement is 0, acceleration is minus 9.81. okay, initial velocity, that is vertical velocity, is u sin theta. We know how much is that. Okay, and time is question mark. Let's find. So which formula suits us the best? S equals to ut plus half at square. So S equals to ut, I hope there are enough spaces here. Okay, I'll try my best. S equals to ut, that is going to be, u is at what speed it was thrown? At 20 meter per second. Sin theta, that is sin 75, S equals to ut sin 75, okay, t ut plus half at square. Instead of plus, I will give minus half, because it's going up, so acceleration is negative, half a t square. Okay, and we know s is 0, so I can just write s 0. Okay, if s is 0, I can bring everything on this side and make it positive, half into 9.81, so 0.5 into 9.81, that's 4.905. I'm bringing them over this side, okay, to make it positive. So 4.905, I'm taking all the space for this question. Okay, t square is equal to 20 sine 75, 20 into sine 75. How much is that? 19.32. So 19.32 t. Can you see one of the t is going to get cancelled from here? So your answer is going to be 4.905 divided by 19 point, sorry, it's going to be, it's wrong. It's going to be, this is cancelled. So t is equal to 19.32 divided by 4.905. So 19.32 divided by 4.905, that's going to be, accurate answer is 9.34, sorry, 3.94 seconds for that ball to travel from here till here. Okay, let's try for second throw. Okay, let me do second throws with some other color. For second throw, same equation, because it's the same situation. I want to find what is the time here. Okay, what time did the second throw take, and difference of both the time is my answer. Okay, so the second throw is going to be, again, s equals to 0, 20 sine 15, if I'm not wrong, it was sine 15 degree. If you see on top, what degree was it thrown? 15 degree, minus half a t square, half a t square, same just like before. Let me give t here, but this is going to be t2. This is going to be t2. Okay, so bring this on the other side. Again, it's going to be 4.905. Okay, t square equals to 20 sine 15, 20 sine 15, 5.18, 5.18. Okay, t, 5.18 t. Okay, so now here how much is this? 19.32. Let me just double check. 20 sine 75, 20 sine 75. Yeah, I'm correct. Okay, so now tt again cancel. You will be left with t is equal to 5.18 divided by 4.905. Okay, 5.18 divided by 4.905. So that is 1.06 seconds. 1.06. I'm taking three significant figure. If I want, I can take them as two significant figure as well, but I'm taking three significant figure here as well. So what is the time they have to wait? 3.94 minus 1.06. 3.94 minus 1.06. How much is it? 2.88 seconds. Let me just double check it from mark scheme and I'll let you guys know. Okay. Yeah, so let me show you guys the mark scheme. Yeah, so yeah, you can see that the answer is 2.88, and I hope you guys understood this question. Okay, so remember, what are the things we did over here? We found the difference of both the timing. The hint here is that it came back to its original position, so therefore s was 0. It's going upward because my vertical velocity is upward. You can see that over here, the vertical velocity is upward, so therefore the acceleration is also negative, minus g. Okay, the time taken is same for both of them. Sorry, the time taken was difference in both of them because they both were thrown at two different timings. Okay, so all we have to do was find the time. That's it. Okay, I hope you guys understood this question.